So in this segment, we'll continue our discussion of identifying user needs. We'll pick up with where we were in the last segment and give you some more discussions. But the first point I want you to appreciate, and we'll have a quick video clip of Dr. Sarkar here, is this distinction between the voice of the engineer and the voice of the customer. And what matters is the customer's needs, the user's needs. So we have to keep that in mind throughout. And understanding what our users needs is a fundamental problem. So let's listen to Dr. Sarkar.
It's important to understand that for the software, it's the voice of the customer that's important and not the voice of the engineer, which is what often happens if you don't completely understand sort of your user needs, right? And actually, unfortunately, there's no real substitute to interacting with your customers directly. I mean, if you can, and if you have the opportunity as a software developer to do that, please go ahead and do that and try to understand directly from your customer what their needs are, what their pain points are. The more varied you can sort of get your customer base, like for example, suppose you're targeting like a medical practice, perhaps go into the academic medical practice as well as the community medical practice, try to get a good sampling, like a sort of a distribution of your users, understand what their pain points are. And they're going to be different. They're going to be different in different settings.
So the process here often starts with meeting your users, and the process will start inevitably with an initial meeting. So maybe those icons there, whether you see that on the table or whether this is a Zoom call or some kind of teleconference or a combination perhaps, those are the icons on the top left. So all these projects start with an initial meeting, and it's critical in the beginning to establish a good working relationship. The usual rules apply of making a good impression. Be on time. Dress appropriately for the environment. If you're not sure, ask what the dress code is. Be on time is actually kind of critical. Hospitals are mazes, so plan to be there early, otherwise you will be late. And if you meet a lot of people in a room, try to figure out who's in the room, their background, and their interest in the project. I don't want to, there's no way to emphasize that enough. You think that your customer is the surgeon, but it may be that the person who will ultimately make the decision as to whether they work with you or not is a person one step down, the nurse, the resident. Because those people often have more time to spend with you. And treat them well, and they'll be helpful to you. And those are important people. Don't just think of the senior people only as your customer. Everybody in that room is important as you work through this. The second piece of advice, and this is going to be, unfortunately, it's the nature of the topic, a collection of advice, but we'll try to make it as interesting as possible. Do not rush to conclusions. So to everybody with a hammer, everything looks like a nail. To everybody who's a database programmer, everything's a database problem. Try to avoid that. Keep your eyes open. And remember, there are two kinds of things that you don't know going into a situation. There was called the known unknowns, things that you know that you don't know, and what's called the unknown unknowns. There are things that you don't know that you don't know that you don't know. And this may sound silly, but that's a critical problem. If you don't know that there's something you don't know, how are you going to find out? So the known unknowns are often easy. You know you don't know them, so you ask. The unknown unknowns are hard, and you have to sort of fish for them. Is there anything else I should know? So you ask questions. Is there anything else I should know? Would you like to add anything? Is there anything obvious that people new to this area do not understand? What are the common mistakes that people make when they start here? What are students confused by? To give you an example that we'll return to many times, in radiology workstations, the images are shown left-right flip. So the left on the brain on your screen is shows the right part of the brain and vice versa. Either you know that or you don't. So you walk into a practice, you listen to radiologists, they will never mention it. They assume that everybody knows this, but you don't. You design your software so the images are shown the right way around, left on the left, right on the right. You'll cause a lot of trouble in radiology. So things like that are important. And you keep not rushing to conclusions. So you must listen, really listen hard, and make sure you understand. You want to ask more questions than to pretend that you understand what's going on and pay the price later. I observe that when I go with students to meet their clinical mentors for my classes project, and they all sit there very quietly, and then they go back and they're confused. This is your chance. Ask questions. And often what helps is to try to restate the problem in your own words. Not just listen, but say, okay, let me try to summarize in my words what I think your problem is. In the process of you restating the problem, they will understand whether you really understand what the problem is or whether you're confused. And this exercise helps. And this is actually, in some ways, the basis for a lot of these documents. By writing a detailed specification and sharing it with your user, part of it is for them to verify that you understand what their needs are. And the only way that they will ever be able to do that is if you express it clearly and often in writing as well. The other thing I would like you to keep in mind is that the problem is not always what it appears to be. So you want to really try to understand what the problem is and what it is not. So sometimes what the clinicians feel their problem is not the actual problem. Sometimes it's just a consequence of some secondary issue that is easy to resolve. I wish I could show this image on top of this image. Maybe that's a trivial problem. It's just as a technical limitation of the system. Sometimes the problem is more fundamental and it's hard to solve. And you have to move, and this is where the picture on the top left comes in of the brown cow model. You would like to move your users in the discussion from how now to what now. You want to move them from I use a shovel to I need to keep my driveway clean. I use a shovel is the how, I need to keep my driveway clean is the what. And this is their real objective, okay? So try to move them out of the details because that's where the new solution is going to come from, ideally. You would like to understand the context of the problem. Why is the problem presented is significant? How many people are affected? How serious is the problem? Why are the current solutions not working? What has been tried before to address this, and why is it not working? Is the problem really quality, affordability, or user skill? So when you come up with any solution to any of these problems, we have a problem. What is the problem deep down? Our current solutions are not good enough. If that's the case, then the problem is quality. You need to design something that performs better. Maybe the problem is affordability. You have perfectly good solutions. It's just way too expensive. So we need to simplify that solution in some way. Maybe it needs cheaper hardware, whatever it is. Or is the problem that we have a perfectly good solution for an expert, but a less skilled user cannot use as a solution? So depending on what the driver is, you may end up going very different directions. So ask yourself, is the problem quality, affordability, or is it we need high-skilled users and we need to simplify in some ways? You need to identify the lay of the land. So what comes before this and what comes after this process or after what we're doing? If we're writing software to guide prostate biopsy, what comes before is the radiology images and the specifications of the lesions. What comes after is that the report of the biopsy goes to a tumor board, which will then discuss what the next step in the process is. Does this patient need radiotherapy? Do they need surgery? Do they need surveillance, left alone for a year and come back for a new biopsy? What happens to the patient prior to this point and what will happen after this, as we mentioned before? Where is the data coming from? If we're analyzing images, is the images coming from a database? Where are the results going to? What format? So where does my output need to go? Is there a custom database? Is there a standard database? Those are all critical pieces. And finally, what constraints does this impose on the problem? So all of these things may mean that we can only do things in a certain way. We need to be able to connect via Ethernet to another system in the room because this is where our data comes from. We are operating in a situation where there is no Ethernet connectivity. All of those things come into play, and we need to understand the lay of the land. You have to map out what comes before, what comes after, what comes in, what goes out, and then you know what the outside constraints are on your system. Things to ask. Is this a time-limited process? If it is, are there things that we can do ahead of time? For example, in the case of the prostate biopsy, the whole process is 20 minutes, so your image analysis shouldn't take 15 minutes of those. Now, much of the analysis, especially anything to do with the MRI images that we showed before, can be done the night before. So organize the workflow that those things happen ahead of time. They're not happening in this critical time with a patient lying there. What are safety and privacy issues and other limitations because of what computers can be used and what cannot? Many hospitals will not touch Mac computers. It's Windows only. Ask about that. If that's the situation, if you develop your software on a Mac, you may find yourself stuck. Ask about regulatory and safety issues that may govern aspects of the problems. We're only allowed to do things a certain way. This is the vocabulary that's specified. Your output should include this vocabulary. Ask about domain-specific conventions. This is the left-right question in radiology, where the images are always shown left-right flipped. You either know that or you don't. And you want to observe a procedure or 2 or 20 or 200 if possible. This is vital in enhancing your understanding of how now. There is no substitute to watching people work, and not just one user, but multiple users at different levels, because that's how you understand what's going on. Not what they tell you, but what they're actually doing. Because what they tell you may be the things they find hard, but you need to understand the rest of what they're doing, because those may be things that computers find hard and users find easy. So you need to understand how now fairly clearly. And there are a few traps to avoid here. as I mentioned before, do not let the clinician's idea of the solution necessarily bias the solution. They also don't know what they don't know. They start telling you, well, we need to use this type of algorithm. That's where you say, okay, thank you. Let me think about that. And the big issue, and this is where I have found myself falling into the trap many times, is the current way of doing things may not be due to technical incompetence. Medicine sometimes feels that it's in the Stone Age technologically, and we think, okay, well, these people are not particularly bright. That's why they're doing this. But there may be good reasons for some of the current practices, and try to identify what is critical and what is accidental. The current methods, for example, may be constrained by legal or regulatory issues, and it has to be done this way because it has to be done this way. And there may be a better way, but you have to change the laws first, and if you can't change the laws, you're stuck doing it the way they're doing it. And finally, a list of sort of additional considerations as we conclude this section. Most of your needs may stem from how doctors and nurses interact with the software in a particular application, but there are stakeholders, however, who are outside of that list. So for example, hospital managers, and this may require particular integration with specific EHR products. Information technology requires specific cybersecurity features. Distributors may need ease of installation or cloud-based upgrades or all kinds of things like that. So the take-home lesson, if you remember nothing else from this slide, is that the user may not always be a user. So when we think about software, we think, okay, the user is the person who touches the software. The reality here is expand your notion of a user to that of a stakeholder. Your user may be somebody who just gets the output of your software for them, and they go on to do their work. That is also a user. Their needs need to be reflected. Your user may be IT because your software needs to connect in a specific way to a specific thing. They're not really a user. They will never touch your software, but they're a user. Their needs need to be met. So the user is not always a user. That's a point that you need to keep in mind as you identify user needs. This concludes our sort of overview of user needs. In the next segment, we'll get a little bit more concrete, and we'll discuss the user's needs situation and how we identify them for the image-guided neurosurgery project. Thank you.